Good afternoon. Welcome here at the side event on decarbonization of road transport. This event is organized by 4 organizations who are all represented by one speaker. We'll be first having Bill Gillett from ESAC, the European Academy's Scientific Advisory Council. Then as a speaker, we'll have Gunnar Luder from the Potsdam Institute for Climate Science. Thomas Fabian is following him. He is representing the European Automobile Manufacturers Association, ACA. And then finally, we'll have as a speaker, Adam Reed from PedalSmart. After the speakers have given their presentations, we'll have a panel discussion. And I would also like to stimulate you to use the Slido app so that you can ask questions. We'll select some of the questions for the speakers later. So with that, let me invite Bill Gillett to take the floor. Bill is a chartered engineer with a PhD in energy studies. He worked for 14 years at the European Commission, mainly for the Director General for Energy. And since 2014, he has been the director of the ESAC Energy Program. He has edited the ESAC report on decarbonization of transport, which was published in 2019. Bill, could you take the floor?
Thank you very much for that kind introduction, Wim. First slide, thank you. It's my pleasure to speak today about how to reduce carbon emissions from road transport. As Wim has just said, the European Academy's Science Advisory Council represents all the national science academies of the European member states, Norway, Switzerland, and the United Kingdom. And experts nominated by ESAC's member academies produced a report in March 2019 on the decarbonisation of transport. And what I'm going to say today will be largely based on that report, which, like all ESAC's work, is free to download from the ESAC website. ESAC is also the regional network for Europe of the Inter-Academy Partnership, which I'll mention a bit later, which has networks of academies in Africa, Asia, and the Americas. ESAC's mandate is to provide independent science-based advice to European policymakers. Next slide, please. Why are policies for reducing greenhouse gas emissions for transport so important? Well, transport produces nearly a quarter of all greenhouse gas emissions in the EU, and its emissions are rising faster than those of other sectors. Nearly 3/4 of all transport emissions come from road transport, and nearly 3/4 of road transport emissions come from cars and small vans. The rest comes from heavy-duty vehicles and buses. Next slide, please. Many different actors need independent science advice to decarbonize transport, and I'll highlight just a few from this list. Regional and city authorities need advice for decisions on infrastructure and local policies. Their urban mobility plans influence the behavior of individuals, businesses, and investors. Automotive and battery industries also need advice for choosing materials and choosing manufacturing processes to make their vehicles. Decarbonization of transport must address both the operating emissions produced when vehicles are driven, but also the embodied emissions produced when vehicles are made. The manufacture of low-carbon batteries is being promoted in the EU to avoid importing batteries with high embodied carbon from Asia, where they're made largely from electricity generated using coal. Electricity suppliers need advice because they have to convert to supplying renewable electricity from hydro, wind, solar, and biogas. Investors and bankers need advice to avoid greenwashing. They're working on criteria for environmentally sustainable investments, known as the taxonomy. And of course, consumers and businesses need advice on how to act. 3 types of action have been identified, and I'm going to speak about these now: avoiding, shifting, and improving motorized transport. Next slide, please. This slide illustrates these 3 types of action. Some foods, such as chocolate cake, we enjoy, but they may have to be avoided. We can enjoy apples instead. Those who usually eat on their own will find that a shift to eating together with others can be more enjoyable. And sometimes we need to use new technologies to improve our health. So I'm going to talk about avoiding, shifting, and improving. Next slide, please. Here are some examples of avoid, shift, and improve policies for transport. Avoiding motorized transport by walking and cycling, sometimes called micro-mobility, is becoming more popular, but it requires investments in local infrastructure for safety and to avoid conflicts with other transport modes. The COVID pandemic has shown us how easy it is to avoid motorized transport by working from home and teleconferencing. Carbon emissions can also be reduced by shifting to more efficient transport modes with the help of information and communication technologies, shifting passengers out of their cars and onto buses, trams, trains, etc. Most of us travel less than about 25 kilometers a day, except when we go on holiday. Shifting freight from trucks to railways and waterways is also an important part of the shifting agenda. Vehicles can be improved to produce less greenhouse gas emissions, for example, making the vehicles lighter, improving their aerodynamics, and reducing their rolling resistance by using better tires. Label and regulate is possible to reduce the demand for oversized cars. The IEA reports that SUVs were the second largest contributor after power generation to the increase in global carbon emissions between 2010 and 2018. So we need to do something about choosing oversized vehicles and engines. Also, using battery electric vehicles is good, but it will only reduce greenhouse gas emissions if they are supplied with decarbonized electricity, for example, renewable electricity. For applications that are difficult to electrify, such as long-haul buses and heavy goods vehicles, options to improve emissions include green hydrogen with fuel cells. The green hydrogen is made by electrolysis using green electricity. And vehicles powered by green hydrogen need approximately 2.5 times as much renewable electricity per kilometer as battery electric vehicles. So the costs will be higher using green hydrogen unless it's imported from very sunny or windy countries with low renewable electricity costs. The second option is sustainable biofuels, but biofuel resources will be limited. Land is needed for food, and land use change, for example, cutting down forests, can reduce biodiversity, so we want to avoid that. Next slide, please. Public information and forward-looking mobility policies are needed to guide the behavior of authorities, individuals, businesses, and investors. In 2011, the EU White Paper on Transport stated that curbing mobility is not an option, but the COVID pandemic is showing us that this policy is out of date. Digital communications and video conferencing permit us to avoid traveling. I mentioned electric vehicles. Woody biomass should only be used to generate electricity for transport after a cascade of uses that maximize its economic and environmental added values. For example, wood should first be used for long life applications like construction timber, furniture, or board, and then reused and recycled before being burned to produce electricity for transport. To harvest trees and burn them increases carbon levels in the atmosphere until new trees have grown to replace them, and this takes decades. In other words, forest bioenergy may be carbon neutral over centuries, but it's not carbon neutral over 10 years, which is the time, of course, that everybody at COP is talking about that we have left to limit global warming to 1.5 degrees. Next slide, please. To conclude, there is no silver bullet, but here is a checklist of key actions that need to be taken by policymakers to decarbonize transport. Incentivize actions to avoid, shift, and improve motorized transport. Invest in renewable electricity and alternative fuels infrastructure. Stop all subsidies for fossil fuels and regulate to phase them out. Invest in public transport, trains, trams, buses, and waterways. Invest in solutions with low life cycle emissions, such as low carbon batteries, hybrid electric vehicles, hydrogen and fuel cell vehicles. Regulate electricity markets to encourage the use of electric vehicles and to manage flexibility and storage on electricity grids. Extend the emission trading system to accelerate the change to low carbon transport fuels. Help the automotive industry to create high quality jobs by producing vehicles with low life cycle emissions. In other words, low embodied and operating emissions. Provide independent guidance for citizens and businesses on how to buy environmentally sustainable products and services. Last but not least, decarbonisation policies must be socially accepted and must not leave anyone behind. Although they are economic in the long term, many sustainable solutions have high upfront costs. So funding must be provided to disadvantaged and low-income groups so that they will not fall into energy poverty or mobility poverty. Next slide, please, last slide. Finally, I would like to tell you about a new initiative which is being led by NASAP, the Inter-Academy Partnership for Africa, the Network for Africa. Building on ESAC's report, NASAC is starting to work on a report on the decarbonisation of transport for Africa. This work will begin with an online workshop next week, 15th to 17th of November. Anyone interested to contribute to this work, either technically or by providing funding, is warmly invited to participate in this workshop. Please register as soon as you can. Thank you for listening. There's much more information in the ESAC report, which you can download for free from the ESAC website. I look forward to your questions via Slido. Thank you very much. We can't hear you, Wim.
Thank you very much, Bill. Thanks for your fine presentation. We'll certainly come back to some of these issues in the discussion. Let's move on to the presentation by Gunnar Luder. Professor Luder leads the Energy Systems Group at the Potsdam Institute for Climate Science and is the lead scientist for the REMIND Integrated Energy Economy Climate Model. He also holds the chair of Global Energy Systems Analysis at the Technical University Berlin. He contributed to the multiple UNEP emissions gap report and recent IPCC reports, and was recognized as one of the world's most highly cited researchers in 2019 and 2020. Gunnar, may I invite you to take the floor?
Yeah, thanks a lot, Wim, for the kind introduction. It's my pleasure now to have a chance to discuss climate neutral transportation in the context of the overall energy system transformation towards climate neutrality. Next slide, please. So this shows, apologies for the slightly busy slide. What this shows is a breakdown of CO2 emissions by sector. And as you know, climate neutrality means that we achieve a balance in sinks between greenhouse gas sources and sinks. And that actually means, because we have also non-CO2 gases, which are hard to abate, for example, from agriculture, that to achieve climate neutrality by 2050, we will need to achieve net zero CO2 a few years before, around about 2045 in the EU, to be consistent with the EU Green Deal targets. So if you look now at this breakdown of CO2 emissions by sector, we see the bluish and purple colors, which are demand side emissions of CO2 combustion of fossil fuels on the demand at the end users, is actually the key bottleneck towards reducing emissions. And actually the transport sector is a key part of this here in the dark purple color. And if we take a closer look at that, we realize that light duty vehicles, LDV, and freight are an important part of that. But then there's also shipping and aviation, which comes on top and also has a major share in emissions. And this will be very difficult to decarbonize and reduce. And of course, because there might be some sources of CO2 emissions that remain positive, all still by mid-century, we still need some opportunities to create negative emissions, and chances are that natural things will not be enough. So we need something like bioenergy in combination with CCS to achieve net extraction of CO2 in the atmosphere. The scale of these negative emission requirements is very strongly determined by how quickly we achieve reduction in these difficult to decarbonize sectors. Next slide, please. So while this is, of course, a very big challenge to achieve climate neutrality by mid-century, there are also a number of very encouraging developments. And on the technology side, it's really a very rapid scale of innovation in a particular type of technologies. One very important development of the last 10 years is a drastic decrease of electricity generation costs from solar and wind resources. So we had an 85% reduction over the last decade in solar PV generation costs. That's even steeper than most optimistic scholars have assumed. And next slide. If we look at battery technology, on the next slide, please, which is of particular importance, of course, for the mobility sector, we are seeing a trend that is very encouraging and that goes into the same direction as what we have observed in the past regarding renewable electricity generation. So chances are that battery technologies is kind of the new photovoltaics, the kind of disruptive technology with very rapid improvement that will help us towards reaching our climate goals. And what's important is, as you see in this, on this graph, it's not only about reducing costs, it's also about improving technology performance. And what's the key for the mobility sector is that you reduce the number of the volume and the mass that is required for a certain performance, for a certain battery energy storage capacity. And that also is increasing quite rapidly. Next slide, please. So going back to the system perspective, it's really important to recognize that in this decarbonization challenge, there's a fundamental asymmetry between electric and non-electric fuels. So if we look at different scenarios, model-based analyses of future developments here on the left-hand side, a very robust finding is that if you have serious climate policies in place, you can achieve very rapid decarbonization of electricity supply. In the European context, that would be in the order of 80 to 90% reduction of CO2 emissions per kilowatt hour of electricity delivered. And that's mostly on the back of rapidly scalable, meanwhile also cheap renewable electricity that can achieve this. By contrast, if you look at non-electric fuels, and importantly, those non-electric fuels currently account for roughly 80% of our energy consumption, the picture is quite different. So there we have a bit of bioenergy, sustainable bioenergy that we can use. Maybe in the future, hydrogen and electric synfuels will also help us, but it will take a much longer time to achieve substantial reductions in the amount of fossil CO2 emissions per kilowatt hour, megawatt hour of energy provided. And this now on the right-hand side has very important implications for the overall economics of energy. And what we see is that while in the past we all grew up in worlds where electricity is the most important and the most precious energy carrier, that to the extent that we have further technological breakthroughs with renewable electricity, and on the other hand also have carbon pricing that is required to reach our climate targets, that all of a sudden electricity will become the cheapest energy carrier, and that will help us a lot in achieving our climate goals. Next slide, please. So the big question is now on this improved category, as Bill said in his earlier presentation. Basically, we are faced with two options. One is direct electrification by using that cheap electricity directly in, for example, battery electric vehicles. And the other option is to use electricity converted to hydrogen and then possibly converted to synthetic fuels. So that's something that we call indirect electrification. What's very important in weighing between these options is to acknowledge that there's a big difference in terms of the overall efficiency of the process. So direct electrification is very efficient. Electric motors are very efficient. But if you go to indirect electrification on top of these efficiency losses that you have for converting electricity to synfuels, you also have a relatively inefficient combustion engine with around about 30% efficiency, which gives you a big gap. So overall, direct electrification is really the much more efficient choice. Next slide, please. Another thought, it's really important to think about the decarbonization of transport, not only single-mindedly through the climate mitigation lens. It's really, there are very substantial other externalities or like environmental side effects from mobility that need to be kept in mind, and that's noise. Congestion is a huge issue to the extent that people drive cars, they take away the space of others. Air pollution is a big problem in accidents. Given these numerous externalities, which all are similar in scale with regards to the social cost and the social harm that's inflicted, it's really important to think about holistic strategies for a transformation of the transport sector. So next slide, please. If we take all these things together on policy implications, it's important to recognize that the European Green Deal really requires a massive acceleration of decarbonization efforts. And we're talking about a scale up compared to previous decarbonization by roughly a factor of 3. So it's really, it's a step change. It's not like a marginal change that we're talking about. So we have very encouraging technology developments on battery electric vehicles. And that's particularly important because that makes most efficient use of renewable energy resources. But of course, we have also to recognize that this requires additional system integration efforts. For example, charging infrastructure, that's a huge bottleneck for the scale up of this. On the other hand, indirect electrification, especially via hydrogen, might be an important option, for example, in the freight market, but it's costly and has specific efficiency penalties, especially if you do indirect electrification all the way to synthetic fuels, which remain scarce and expensive, and it will take time to develop those markets. So we cannot rely on the availability of synfuels and allow us to delay a transition to battery electric mobility, especially in the light duty vehicles. So on the policy side, carbon pricing is very, very important to incentivize the decarbonization of the energy supplies. But then we also need additional policies to accelerate the transition of the fleets, because that's a key inertia lies with the fleets, and that can best be addressed with direct policies such as emission standards for the fleet. And then to address these other externalities, most of them are important, especially in the urban context. We also need broader sustainable urban mobility concept to achieve a more sustainable overall transformation of the transport sector. Thank you.
Thank you very much, Gunnar. We now move to the presentation by Thomas Fabian. Thomas has been about 3 years the commercial vehicle director at the ACEA, which is the European Automobile Manufacturers Association, which represents the 7 major truck producers in Europe. Before that, he's held various positions associated with transport. In particular, I'd like to mention that he served as the head of the Department Commercial Vehicles, Trailers, Bodies and Buses of the German Association of the Automotive Industry. But he's also been the Director of Transport Policy for the German Airports Association, something that we won't touch on so much today. And he has been the scientific advisor to a member of the German Parliament. Please, Thomas, take the floor.
Thank you very much, and good afternoon, everybody. It's an honor and a pleasure to be here today and to be able to contribute to this event. I can build upon what Gunnar just described. Next slide, please. COP26 obviously is hugely important for us. Many pledges and commitments have been made over the last few days, and they sure help us plot the path to climate neutrality. In the next few minutes, I would like to focus, though, on the how. How do we reach climate neutrality in road transport, especially in road freight transport? because our commitment to do what is necessary and what can be done and what we can do is very clear. Now, in road transport, it was mentioned before, we're facing two main challenges. One is the fact that we have seen growing CO2 emissions over the last decades. Vehicles have steadily but gradually become more fuel efficient over the years, but these efficiency gains have been compensated by the growing transport demand. So making vehicles more efficient has always been a top priority for the truck industry, as this is a key competitive factor. But cutting emissions by a few percentages per year is not enough anymore. Next slide, please. The second big challenge that we're facing is the average age of the vehicle fleet, which today stands at about 12.5 years in Europe. There's quite a spread between different vehicle segments and obviously between different member states. But for us, it means that we have to take the fleet renewal into account in our strive for climate neutrality in the road transport sector as a whole. Next slide, please. Already a year ago, all European truck manufacturers expressed their commitment to carbon neutrality by 2050 at the latest. Together with the Potsdam Institute for Climate Impact Research, we have laid out that carbon neutrality by 2050 at the latest inherently implies that already by 2040, all new commercial vehicles sold must be fossil-free. Together, we have identified what the key building blocks are to set us solidly on this path to climate neutrality. The first, obviously, functional, reliable, and efficient vehicles are a key factor. This is clearly our responsibility as vehicle manufacturers, and we're ready to deliver. The second, a sufficiently dense network of charging and refueling stations to enable the operation of these new powertrain trucks and buses. And the third, equally important building block is a coherent policy framework which enables and drives this transition. This is key as a fundamental restructuring of the industry and ultimately of the value chains of all sectors that depend on commercial vehicles is what is necessary, and it is already beginning to happen. Now, let me dive a little bit deeper into this. Next slide, please. Reliable and efficient zero-emission vehicles are already beginning to hit the market. We're convinced that the new powertrain technologies will fast become the backbone of road freight transport. Truck manufacturers are investing heavily in these new solutions. Battery electric vehicles are the first zero-emission technologies to reach the truck market, and they're closely followed by hydrogen-powered trucks. Now, road transport, especially with heavy-duty vehicles, is widely seen as a hard-to-abate sector where cutting CO2 emissions is particularly difficult. And that is true, not the least because of our customers' focus on total cost of ownership, the TCOs. The TCOs for low and especially zero-emission vehicles just need to be better than there are for diesel trucks. And our customers need to be able to operate these vehicles more profitably than they can operate the diesel-based ones today. If they're not, they will just continue to run the conventional vehicles. This may be one of the reasons why that some think electrification, be it with battery electric or hydrogen-powered fuel cell electric vehicles, is still far away in road transport, but that is not true. The new powertrain vehicles are coming fast. Already by 2025, we will see a total of at least 40,000 battery electric trucks in operation in Europe. And by 2030, by the end of this decade, there will be several 100,000 of zero-emission trucks in operation. By the end of the decade, anywhere between a quarter and maybe up to half of all new registrations in some use cases will have to be zero-emission if the infrastructure and the enabling conditions, that means the supportive policy framework, are in place. Contrary to popular belief, the majority of these vehicles will be heavy duties operating in long-haul missions, because this is where the majority of the emissions are. Now, I mentioned this, these vehicles will require a dense charging network that is fit for purpose. Every single one of them will require a depot charger at the home base. But in order to allow the variety of essential missions that these vehicles perform, we need publicly accessible charging and refueling stations suitable for trucks, buses, and coaches. A successful market deployment of zero-emission vehicles will only be possible if a dense network of the appropriate infrastructure is rolled out rapidly. This is not a chicken or egg issue. The infrastructure must become available quickly, as transport companies need the certainty that they can fulfill their transport missions. Truck manufacturers, together with fleet operators, will of course play an active role in developing the network of charging stations. But policymakers at the EU and national levels must take urgent action to make this possible. Everyone needs to live up to the challenge we're facing together here. Now, as a matter of fact, clean electricity, hydrogen, and also low and zero carbon fuels are crucial for the transition. Even though the additional power demand that the new zero emission vehicles will need may be limited in total, we still need to make sure that they can be charged 24/7 at their individual locations with green electricity, green hydrogen, and with low and zero carbon fuels. So all energy carriers that are used in road transport will have to be green and based on renewables as quickly as possible, not the least to allow contributions to the necessary emission cuts from the rolling fleet, the existing vehicle stock that may take some time to get replaced. Now, this brings me to the last but equally important building block. Zero emission vehicles will not take off as long as diesel remains cheaper. In spite of technology improvements and all our efforts, we see a persisting TCO gap for zero emission vehicles. But as I said earlier, these will simply have to become the better option, the preferred choice of transport operators. For this to happen, we need a comprehensive carbon pricing system, which drives the deployment of zero emission trucks and which adequately reflects the total costs of CO2 emissions. Now, science and truck manufacturers, together with the Potsdam Institute, we agree that the price of carbon must increase to much higher levels than today if we want to shift the sector to carbon neutrality. Now, the truck industry is ready to change and we're ready to lead this, but we can obviously not do this alone. We urgently need deeper engagement and collaboration with policymakers, the entire value chain, and last but not least, also with citizens to navigate and accelerate this transition. So thank you very much. Happy to take your questions.
Thank you very much, Thomas. We'll now go to Adam Reed, who is the founder and CEO of PedalSmart. He has supported multinational technology corporations for over 20 years and founded PedalSmart in 2015 to change transport within the last mile. Following market engagement and the resulting design process, the FlexiQuad will enter the market in the first quarter of 2022 as an alternative to cars and vans, with trials across the public and private sectors to support their race to zero ambitions. That sounds good. Adam.
You're still on mute, Adam, I think.
I'm sorry about that. Hi, my name's Adam Reed. I'm the CEO and founder of PedalSmart. Thank you for the opportunity, Will and William. We're the manufacturer of zero carbon pedal electric vehicles that's due to enter the market next year. The main target market is the B2B market, public sector, private sector, and following that, the consumer sector. Next slide, please. Thank you. The ability to use cycle lanes, pedestrian lanes, and bus lanes is key to making changes in our urban areas. The reduction in urban traffic, the race to zero, the reduction of transport times by up to 80%, and overcoming inclusivity constraints, which was highlighted in William's piece. And overcoming the last mile urban commuting challenges, especially in the commuter section, both from a business point of view, a public sector point of view, and a consumer point of view. Next slide, please. So the urban, this is our range. The urban 100 is our commute range. It covers food, freight, people carrying, a services vehicle, and our timelines, as has been said, is early 22, with pre-production phase later on in the year in mid 2022 and full production in 2023. Next year, we're focused on the UK market initially and then looking for distribution in the international market. Our key markets are manufacturing and campus sites, logistical organisations who we have demos for planned for Q2, and charities and social enterprises who currently rely on different forms of transport, but mainly grants and support based. Also, the public sector is a key aspect in regards to last mile, but also the logistical needs. Typically, the problems are pollution, the congestion, the operational and commuting aspect within our businesses, the efficiency of operations. Currently, with the restrictions with traffic as it is at the moment, timescales are long. By reducing those timescales and making the operational process more efficient, there is benefit from a cost point of view and an operational point of view for those organisations who are in logistics. But for the riders, there's the active travel aspects. There's the health point of view. There's the quality of during their working life. So that is a key part of it. But also, using pedal electric vehicles reduces and changes the licensing requirements. So it opens up opportunities for part-time workers, graduates coming out of academic institutions, those who are currently homeless, and those that currently are looking for part-time work to help pay the bills. It's opening up the market to support organisations with a whole new range of people to do the work. The entrance of pedal electric vehicles is not just an operational element. It's not just about carbon. It's also about supporting the community and about bringing work and health to those people that deliver and use commuting services. Next slide, please. This summarises our route to market, but also it summarises pretty much the route to market of most of the people in this space, that most of the people who are providing pedal electric type vehicles. If the view is 80% of organisations and individuals will be in urban areas, it's important to use the road network effectively. By using the wider network, the bus lanes, cycle lanes and pedestrian areas enables businesses to benefit from the more efficient delivery services, but also for commuters to get from public transport through to their end choice, whether that be restaurant or whether that be for work. Integrating both people carrying and freight is a key part of the pedal electric market. Integrating pedal electric with EV is a key part of urban change, urban transformation. Other areas in our roadmap are that we're looking to enhance the vehicles to incorporate those that have inclusivity issues, both poverty and health. Those with mental and physical disabilities may struggle to drive cars, may struggle to be able to manage and own their own commuting. The idea is to bring a range of vehicles, pedal electric vehicles, that enable these guys to effectively get around in urban areas. But also support the homeless, those individuals who've fallen on hard times and are struggling to effectively commute, but also get active work. For those people coming out of universities and colleges and schools that are struggling to get work, this is an open opportunity for them to have ad hoc, part-time or full-time work. Working with academia in regards to our R&D, to work with organisations to offer students the ability to get into the design and the development during our R&D process. So effectively building a skill set and a job opportunity when they qualify. Also in our roadmap is the provision of data. Data is key to understanding the market, to understanding urban transformation. Our vehicles will carry sensors for environmental, pollution and performance data tracking. But also the vehicles will be going around urban areas across multiple sectors and therefore can very much help in the telecommunication space with 5G and 4G and wireless technologies. Also giving access to the users from a dashboard point of view. So you have integration of both people carrying and freight. In rural areas, that's a key part. If you've got traffic and you're looking to reduce the traffic by merging different types of logistics together, enable you to reduce the amount of cars and transport on the roads. A data and API integration is a key part of that. So essentially, PedalSmart will be working with our partners, not only to bring out the vehicles, but also to bring a range of benefits through public sector into software application to benefit urban transformation and jobs in the future. Next slide, please. This slide has been presented at COP26 already. It's basically demonstrating our saving. There has been analysis done of our vehicle. Essentially, the outcome is it's a pedal electric vehicle. Its carbon saving is considerable in regards to the current diesel and petrol vehicles. The outcome is with 1% of the market on a global basis, there's a half metric ton of carbon saving. With 75,000 vehicles, there'll be a 0.1 metric ton of carbon saving. There is a considerable carbon saving. However, the key part of pedal electric vehicles and the development of this technology would enable the community to access vehicles where they don't currently have access, to effectively give jobs, both from a technical point of view, but also a logistical point of view. Next slide, please. So just to round up the last slide, effectively, the pedal electric vehicles is entering trials next year. Our main focus will be around two vehicles, the Urban 100 with 100 kilo carrying capacity and the Urban 200 with a 250 carrying capacity. Those will enable organisations to establish whether pedal electric vehicles are a viable alternative or could be an addition to their existing fleet. Next slide, please. Thank you for this opportunity and happy to accept any questions later on. Thank you.
Thank you very much, Adam. We now turn to the questions and answers, and I would like to remind the audience that you are invited to use Slido. We just had the first two questions come in, and I would actually like to take the opportunity to start with the first question that we had. I'll read it out. Wondering on how holistic is our approach to net zero? Do we have a confirmed plan or even a thought of one on waste management coming from electric vehicles? That's already looking ahead to having electric vehicles. Maybe Thomas, since you represent the industry, is there a plan to already think about the waste management coming from electric vehicles? I guess that also means refurbishing and recycling.
Yes, eventually, of course. Eventually, of course, we need to take this into account as well. I mean, for the moment, of course, we need to focus on bringing those vehicles to the market and making, as I described it, making them the preferred choice of our transport operators. Of course, eventually, in order to cut the emissions as a whole and to reach climate neutrality, we need to turn the whole economy into a circular economy, and vehicles will, in that respect, have to play their role. This is already to a large extent the case with respect to many vehicle segments. But again, the focus for the moment, the short-term and urgent focus is bringing those vehicles to the market and making them the preferred choice, the most viable, economically beneficial choice of our customers.
Okay, thank you. Is any one of the other speakers interested in reflecting on this issue too? Gunnar?
I could add a thought. So from my point of view, the main difference when it comes to material requirements between electric mobility and conventional cars is really the battery cycle. And if you think about material flows, it's really both the provision of materials and then use phase to the less extent than the end of life. But of course, what is a crucial bottleneck is the new materials that we need for batteries that we didn't need in the conventional world. So really, like, the low carbon transition for transport, to a large extent, is also a paradigm shift in our resource uses. So we go from fossil resources to a lot of mineral resources that we haven't required to the same extent in the old world. And we really see that if you take the entire energy system decarbonization, one of the most crucial bottlenecks is battery materials, lithium, cobalt, nickel. And these are resources of concern because they are scarce and because they currently, some of them are, like in many occasions, they aren't produced in a sustainable way. So there are possibilities to make that more sustainable. There are more geological resources expected, but currently the supply chains are very, very difficult. They aren't sustainable, and it's a big challenge to make them sustainable. And I think a truly sustainable transport decarbonization needs to also account for those supply chains, many of which are outside of Europe. So really, having a regulation of supply chains is the only way to make sure that our electric cars and new mobility concepts are truly sustainable.
Thank you, Gunnar. I think Bill would also like to contribute to this.
Thank you, Wim. I was just going to, I'm not an expert in this, but I was going to comment on some of the discussions that were held in our expert group when we were drafting this report. I remember there was a lot of interest in a second life for the batteries in stationary applications to help with the balancing of electricity grids, because with electric vehicles, it isn't a good idea to keep the battery for a long time in the vehicle because it reduces its capacity, but it's not actually finished and it can then serve in stationary applications. So I could see there is definitely an interest in the marketplace for that. I don't know the latest thinking on that. That's already 18 months or so ago, but I could imagine that market still existing. The other thing which is of interest to me, and I would be most interested to hear Thomas's view on this, we have vehicles with a lifetime these days of 15, 20 years, and we're going to try to phase them out because of their engines. Is the automotive industry serious about a circular economy? Can we use the wheels again? Can we use the seats again? Can we use the windscreens again? I mean, what could we be doing more sensibly to actually have a proper circular economy for the vehicles that we're driving around and to bring them up to date with the powertrain of tomorrow, but maybe using recycling and not wasting the materials that we have?
Okay, thank you, Bill. The second question which came in is associated, or it touches on using hydrogen. And before we maybe take the question or the last one that is on the screen now, I'd like to connect. Gunnar made a strong point that using hydrogen as in the powertrain is much less efficient than using electric energy directly. Nevertheless, it's often stated that for the really heavy transport, the electric power generation is not sufficient at the moment. Thomas, would you be willing to reflect on this? I mean, do you think you can get far by using electric energy directly rather than hydrogen?
Thank you for the question. Excellent point. And I mean, this is our view when it comes to when we use the term technology neutrality, right? I fully share Gunnar's statements that direct use of electrification of electric energy is the way to go. It seems to be the most efficient one. But still, we have certain limitations that are the weight of the battery. I mean, lots of technology improvements there. The weight of the battery, as I mentioned, when it comes to professional commercial transport operators, of course, they're very sensitive with respect to payload restrictions. But also, you could think as an example of coaches recharging a battery-driven battery electric coach over like 45 minutes, an hour, or maybe even longer, may not be the choice that many would like to, the time would like to sacrifice for this. So our current understanding is that hydrogen electric vehicles, fuel cell electric vehicles, do have an edge technologically when it comes to certain use cases, certain applications. How this will play out in the market is a different question, of course. I mean, the key question, and that's something we fully share, is eventually this needs to be green hydrogen, right? And the cost of energy conversion needs to be taken into account. But from today's perspective, I mean, we're doing everything we can to bring the zero emission vehicles to the markets in as many applications and use cases as possible. But for the moment, we see that both technologies will have to play their role in this transition. Okay,
thank you. I think actually the last question on the screen, which, I mean, this is you are all representing European organizations, but it's bringing us also to other continents. And before we take the question more specifically, I would like to invite Adam, who is also stressing the social aspects of his project to us. Is your ambition also, Adam, to bring this to other maybe less developed countries and where Pedal Smart could also help?
Yeah, we're currently in early discussions with UAE, and we have ambitions for areas in the African region. Obviously, as a vehicle, there are huge cost benefits to it, but also health benefits to it. And it goes across both business sectors, public sectors, and consumers. So it does suit areas. Also in the continent and Africa, they could benefit from other solar paneling, for instance, on it that could have some further benefits, which we haven't incorporated yet into the design, because in the UK and European region, perhaps it wouldn't be as appealing or cost effective. So there are further R&D activities there, but we are currently in early stage discussions with the UAE group about rolling out in Africa and in the Middle East. So key parts of the R&D process are part of that. But in regards to community, I think that decarbonisation is really important, obviously, for climate change, but it's about the community, and it's about both business community and consumer community benefiting from that, and that it adds other value. Having data tracking to it enables you to make serious decisions on it, using academia to, as part of the R&D process, build skill set, and giving jobs out to those people who are struggling at the moment in regards to earning an income. Looking at the African region could definitely help in regards to the R&D process, but also maybe developing the product and manufacturing the product in the region.
Okay, thank you very much. Very, very nice. Can I invite the other panel members to reflect on the question on what way can the most developed countries help Latin America in the changes of means of transport from fossil fuels to electric? Is it just a matter of exporting the trucks which Thomas, the factories of Thomas are producing, or are there other ways where we can help? Bill, is your hand still raised from earlier? Or?
I would be happy to contribute to this point, because I think it's a really important point. This solution is a global, I mean, we're looking for a global solution because we're all suffering from the problems caused by global warming. And it's crucial that the Latin American countries also reduce their use of diesel and petrol. And while we today tend to cooperate on the manufacture, and I'm sure Thomas can tell us more about this, how the companies who manufacture in Europe exchange components and in some cases actually sell whole vehicles around the world. We do this by cooperating initially at a technical level. And there are standards being developed now. For example, how do you connect your vehicles to the main grid in a way that can be paid for without too many complications, where it becomes easy for people to do. And these work on common standards across the world, I think, will be a good mechanism for exchanging and helping to bring up understanding in countries which maybe have not done as much work as some of the more advanced nations have done. And my feeling is that the vehicles themselves will probably be very similar, just as you buy a Toyota in 5 different countries, they're all exactly the same. I'm sure there will be a Mercedes or I don't know, Fiat or whatever it is will also be circulating around the world as well. The vehicle is one thing, but I think the standards and the understanding of how to manage that and how to manage it on the grid involves scientific and technical cooperation. And one of the reasons that NASAC is going to be working with the Europeans is to try and share some of that thinking and that knowledge. I think it's crucially important, not just the manufacturers, but the rest of us get involved in helping to make this happen across the world. Thank you.
Thanks very much, Bill. Is any one of the other panel's members wanting to contribute to this? Or if not, then I would like to take part of the last question on the screen. We only have a few more minutes left, which is, of course, touching on the issue that some countries that have a big car or truck company or factories are not so much committed to banning combustion engines by 2040. On the other hand, I heard Thomas actually argue in favor of comprehensive carbon pricing, which is interesting. So it's almost as if the truck companies are arguing for stronger restrictions. Thomas, could you reflect maybe on this last question?
Yes, thank you very much. It's a very important question, and I mean, I think I said this in the beginning of my short presentation. Truck manufacturers are very clear in their commitment to fossil-free by 2040 at the latest. Now, in fact, we're going to see this transition to an ever larger share of zero-emission vehicles in the truck industry accelerating over the next 10, 15 years. But the question here implies, or asks the question, is the European Commission's proposal with respect to the AFIR, the Alternative Fuels Infrastructure Regulation, is this good enough or not? Well, I think it's very clear we need to, it's not the vehicles that will be the bottleneck. We need, and there's no blaming and finger pointing here. We're in this together, we need to solve this together. Truck manufacturers are willing and ready to deliver and lead the transition to bring zero-emission vehicles to the market. The Commission's proposal with respect to the charging and refueling infrastructure is a very welcome and an important step in the right direction. But is it good enough? Is it sufficient? We don't think so, because it is not meeting the ambition level that we're faced with.
Okay.
So what we need to see is a higher ambition. I apologize here. Here's a bit of a background noise here on my side. What we need to see is a higher ambition also with respect to the charging infrastructure, and equally important and crucial is the carbon pricing to drive this transition.
Okay, thank you very much, Thomas. We're in the last minute now, so unless anyone has a very urgent question, I would like to thank all the speakers, and to the audience say that the contribution of ESAC is certainly available online, but also the authors. I've seen the statement actually issued by PIC and the ACEA together. I saw that on the presentation of Gunnar. And also Adam, of course, has quite a bit of information available on the web. So you can certainly find more information if you want to via the web. And once more, thanks to all the speakers. Thanks for joining this side event. And thanks for all your contributions. And thanks for the audience for listening and also for contributing with the questions.
Thank you very much. Bye-bye.
Bye-bye.